The question we are solving now belongs to test series 4. It is of network theory subject. In specific, it belongs to sinusoidal steady state analysis. As per the question, there is a magnetically coupled circuit as shown. The primary is excited by a voltage source of 2 at a phase of 0 degrees and it has a self-inductance of 2 Henry, and the secondary is shorted as shown, and the secondary coil has a self-inductance of 1 Henry and the dot convention is as shown. Please note that the mutual inductance between these two coils is 1 Henry and the circuit is operating at a frequency of 2 radians per second. We need to find the current I2 flowing in the secondary coil. So now let us assume there is a mesh current I1 flowing in the primary coil, and from this we can say that there is a mesh current flowing I2 in the secondary coil due to the current I2 given. And we know that the current entering the dotted terminal of a coil will produce a voltage which is sensed positive at the dotted terminal of the other coil. So by KVL we can write that 1 plus 2j multiplied by I1 plus j omega 2 I1 minus j omega I2 is equal to 2 at a phase of 0 degrees. So upon substituting omega equal to 2, we see that this equation can be written as 1 plus 6j I1 minus j2 I2 is equal to 2 at a phase of 0 degrees. Now similarly upon performing the KVL to the secondary coil, we see that the secondary coil gets simplified as j omega 2 I2 minus j omega 2 I1 is equal to 0. That implies I1 is equal to I2 both in magnitude terms and in phase terms. Now upon substituting the same in equation to 1, we see that the equation gets simplified as 1 plus 4j I1 is equal to 2 at a phase of 0 degrees. So from this we can say that I2 is equal to I1 is equal to 2 at a phase of 0 divided by root 17 at a phase of tan inverse 4. So the current can further be simplified as 2 by root 17 at a phase of minus tan inverse 4 ampere. From this we see that the correct option representing the current I2, that is the current in the secondary coil, is A.